In this getting started video, we will go over material balances. And in the next couple of videos, we will solve actual problems. But this video is just to get started. So a continuous process occurs when input and output flow constantly throughout the duration of a process. So this is an example. A water fountain, it shoots water in the air and then water flows back to the pool and then shoots back up. It repeats this in a cycle. So this is an example of a continuous process. Now a batch process, input is fed into the system, then sometimes later is removed, no mass enters or exits the system between the start and end process. So as an example, if you pour water into an ice tray and then you place it into a freezer, once it's frozen, you take out the ice cubes. So input enters all at once and then product is removed all at once. There's no in between. Now a semi-batch process is any process that is neither a continuous nor a batch. So mass may be added or removed during the process, unlike in a batch process. So as an example, if you remove marbles from a jar one by one until the jar is empty, and the marbles are not placed back into the jar, this is an example of a semi-batch process. Now, material balance is a conserved quantity, and so the formula is input plus generation minus consumption minus output is equal to accumulation. So input is what enters the system boundary, generation is what is being produced within the system, output is what leaves through the system boundary, and consumption is what is being consumed by the system. And accumulation is the buildup within the system. And so if a system is at steady state, then accumulation is 0. Total mass, then generation and consumption are both 0. In rare cases, this is not true. Now, degree of freedom. So degree of freedom, or DOF, is equal to unknowns minus independent equations. And in the next couple of videos, we will be using degree of freedom. So if you're not familiar right now, just take this with a grain of salt. So degree of freedom is equal to 0, problem can be solved. If it's greater than 0, problem cannot be solved because you have more unknowns than knowns to solve. And if degree of freedom is less than 0, like a negative number, problem cannot be solved also because you're over specified. As an example, if you say 10 is equal to 5x and 5 is equal to 5x, you have two equations and only one unknown. The unknown is x. And if we were to solve, we would get x is equal to 2 and x is equal to 1. So this is inconsistent. We can't say that x is equal to 1 for this, and we can't say x is equal to 2 for this. So this is an example of why DOF has to equal to 0. Okay, molecular species balance. Again, next couple of videos we will solve actual problems. And so if you want, you can write down this setup. So you can pause the video here and actually write. Atomic species balance. Again, we will go over an example problem. And extended reactions, another example.